Part 4. Use mathematical tools, table, graph and algebra to determine the time at which the missile hits the ground. The missile is going to hit the ground when h equals 0. Because if h is equal to 0, it means it has no height. So if the missile has hit the ground, h will be equal to 0. There will be no height. So from the table, we can see that h is equal to 0 when t is equal to 6. So h is equal to 0 when t is equal to 6. From the graph, h is equal to 0 where the graph cuts the horizontal axis. So from our graph, this occurs when t is equal to 6. So we can clearly see that this is where our graph cuts the horizontal axis. So this occurs at t is equal to 6. And then by algebra, when h is equal to 0, we take our formula, which is h equals 30 plus 25t minus 5t squared, and we let it equal to 0. So we swap the h for 0. So we have 30 plus 25t minus 5t squared is equal to 0. So we start off by dividing across by 5. 30 divided by 5 is 6, 25t divided by 5 is 5t, and minus 5t divided by 5 is minus t squared. Now we're going to rearrange our equations so that our squared is first, our t is second, and our constant is last. So we end up bringing the minus t squared in front, plus 5t stays in the middle, and the 6 comes to the end. So we've minus t squared plus 5t plus 6 is equal to 0. Now we're going to change the signs. Minus t squared becomes t squared, plus 5t becomes minus 5t, plus 6 becomes minus 6. So now that we have positive t squared, we can factorize. So we end up with t minus 6 multiplied by t plus 1. And then we're going to solve. So we're going to let what's inside the first set of brackets equal 0. So t minus 6 equals 0. So t is equal to 6. And then we let what's inside the second set of brackets equal to 0. So t plus 1 equals 0. So t is equal to minus 1. As t equals minus 1 is not possible, the time cannot be minus 1. The particle lands when t is equal to 6. So the particle lands after 6 seconds. Part 5. If, instead of hitting the ground, the missile hits a target which is at a height of 20 meters above the horizontal ground. Use your table, your graph and algebra to estimate the time at which the target is hit. So the missile hits the target when h is equal to 20. So table. From the table, h is equal to 30 when t is equal to 5. And h is equal to 0 when t is equal to 6. Thus, we would estimate that h is equal to 20 about 1/3 of the way between t is equal to 5 and t is equal to 6, i.e. at around t equals 5.3. From the graph, draw the horizontal line h equals 20. And see where it cuts the graph. Then follow this down to the t-axis. We estimate the time at which the missile hits the target to be t equals 5.3. So this is approximately 5.3. And then by algebra, h is equal to 20, so we let our formula or equation equal to 20. So we just swap that h for 20. So what we're going to do is bring the 20 over the other side, so we get minus 20, and 30 minus 20 is 10. So now we have minus 5t squared plus 25t plus 10 is equal to 0. We're going to divide across by 5 and change the signs. Or technically you could just divide by minus 5. So minus 5t squared divided by minus 5 is t squared. 25t divided by minus 5 is minus 5t. and 10 divided by minus 5 is minus 2. So now we have t squared minus 5t minus 2 is equal to 0. We're going to use our minus b formula, letting a equal to 1, b equal to minus 5, and c equal to 2. We substitute our a, b, and c values into our quadratic formula, or our minus b formula. We end up with 5 plus minus the square root, 5 squared minus 4 multiplied by 1 multiplied by minus 2, all divided by 2. That gives us 5 plus minus the square root of 33 over 2. As t must be greater than 0, t is going to be 5 plus root 33 over 2. Because t must be greater than 0, so we ignore the minus value. And putting this into the calculator and rounding it off to 2 decimal places gives us 5.37. Which is very close to our estimate from the graph, which was 5.3, and the estimate from the table, which was 5.3. Part 6. By finding the change in height in 1 second, find an estimate for the speed of the missile after 5 seconds. An estimate for the speed of the missile can be found by using speed equals distance over time. And this formula can be derived using Dad's silly triangle. So Dad's silly triangle is our distance, speed, time formula triangle. And if we're looking for the speed, then we cover up S and we're left with d over t. So to get the speed, we're going to do distance divided by time. So d divided by t. So speed is equal to distance divided by time. So when t equals 5, h is equal to 30. And when t equals 6, h is equal to 0. Thus, the missile travels 30 meters in the 1 second from t is equal to 5 to t is equal to 6. Our estimate of the speed after 5 seconds is then speed equals distance divided by time, distance being 30 meters, time being 1 second, and 30 divided by 1 is 30. So 30 meters per second. You should note that this estimate is very approximate. In a later chapter we will see how to obtain a speed such as this accurately.